Hi there, this is Tison from Greptime. In our last demo, my colleague Wenjie showed how to migrate data from InfluxDB v2 to GreptimeDB. Just a quick reminder, GreptimeDB offers a fast and cost-effective alternative to InfluxDB, boasting cloud-based elasticity and commodity storage. We found that in production environments, users prefer to self-deploy InfluxDB v1 instead of v2. Perhaps because v2 is mainly designed for InfluxDB cloud scenario and hard to operate manually. However, v1 is in maintenance mode for a long time and lacks a lot of improvement that leverage modern data infra progress. GreptimeDB is flexible for both self-deployment or you can access it more quickly on GreptimeCloud. Also, it supports InfluxDB's LAMP protocol and employ a design that is at least as good as InfluxDB v3. We build it upon cloud-based commodity storage, leverage open-source software like Apache Allo, Flight, Data Fusion, Parquet, Apache OpenDAL, and more. Now, as you may want to give us a try and are unsure how to migrate your data from InfluxDB v1 to GreptimeDB, then you are in the right place. In this demo, I will show you how to do this in detail. You can also find detailed instructions in our tutorial blog. I will attach the link in the description below. Let's start the demonstration. I will follow the instruction in our tutorial blog. So first, before starting, let's check we meet the prerequisite. You need access to your InfluxDB engine path, which contains your data files. For InfluxDB v1, it's typically var lib InfluxDB. I will showcase migrating data from an InfluxDB v1 server in the Docker container in this demo. But as long as you can access the engine path, the process should be the same. Now I will follow the appendix to set up the InfluxDB v1 server. First, let's go to a new directory. For example, make dar migration test. Change directory to this new space, and we copy the command to start a new Docker container which runs InfluxDB 1.8 version. Okay, it's running here, and as it shows, the engine path is var lib InfluxDB. So we start a new shell session, copy the command here to attach a new interactive shell. This is the influx shell we connect to the InfluxDB v1 server, which we start in the Docker container just now. And we change the database, create a database in this shell. Okay, you can see that we create a database named MyDB and run show database, which confirm that we create a MyDB database. Now, let's ingest some sample data into MyDB. Let's start a new session here. Download the LAMP protocol file from internet. We can see the sample data here, and it's about 5,000 lines in the LAMP protocol format, and we run the InfluxDB HTTP API to ingestion this data to the InfluxDB v1 server. Okay, success. And now we ensure the data is ready. Back to the interactive shell, use MyDB and select count. We see that there is 5,000 lines of data. Okay, so now the sample data is prepared. Before we migrate this data to a GreptimeDB server, we need to get a provision of GreptimeDB first. You can self-deployment on GreptimeDB server, follow our documentation. But in this demo, I will show you how you can get a GreptimeDB cluster freely on Hobby Plan service on the GreptimeCloud. Click this link, head to GreptimeCloud, and log in with your Google account or GitHub account. I will choose Google account, choose my personal account. Okay, here I have some existing service. I will create new service. If you are a new user, there will be an introduction which guide you to start a hobby plan. We choose hobby plan and click next step. Generate a service name. The description can leave to blank. Click next step. Now we can get a new provision in a few seconds. We should prepare the environment variable, which in our following script that migrating data, we will use these environment variables to configure the host name and username password. So we copied this command on our shell and fill their value one by one. We click connection information. This is our new GreptimeDB cluster. Fill the host, fill the DB name, username, and password. Okay, we're set up. Now we export data from InfluxDB v1 server. As we set up the server as the appendix, we run the following command. We change the environment variable, configure database as MyDB, we just create now, and configure the engine path to the default var lib InfluxDB. We run this command, which means that we execute InfluxDB inspect export in the InfluxDB v1 container. Okay. We now write this export data in the Docker container. And thus we need Docker cp, which means Docker copy, to copy this file to our host machine. Okay, now you can see we have an InfluxDB export LAMP protocol file. Let's check its content. Also LAMP protocol data format. What's more, we showcase a very simple usage of Influx inspect command. You can specify more concrete data set like time range to be exported. You can refer to the InfluxDB inspect export menu for details. Anyway, now we have the exported data in our host machine. Let's split this data into some small data files. Because this is showcase you migrate a small set of data, but if you have a large of data, for example, a few GB or a few 100 GB, you need to split the data into some small slices, and then you ingestion by partitions. And because we're using hobby plan here, we need to split the data in less than 1000 lines so that we don't hit the rate limit. Okay, now we can check that the export data is slipped down into a few slides. And we run this script to import data to GreptimeDB via the HTTP API. You can see that we iterate over this slide data file and import, also write the data to GreptimeDB host using the InfluxDB v1 HTTP API and configure the username and password. It will take some time that we ingest these data slides one by one. Okay, now it's done. All is success response. And we can go to the web dashboard to check the ingested data. So this is the cluster we config. We go to its web dashboard. And we can see the error sensor table here. We can click quick query and query this table. We can query some sample data and see that there is some error sensor data here. We can also use standard SQL to do some complex query like count the total. Okay, it's the same 5000 lines of data. and we can do some complex query like min-max. Check for the time step. Okay. So the error sensor data is fake generated, and we can find a time a few minutes before now and in a future time from now. So why would you want to migrate from InfluxDB to GreptimeDB? The first obvious reason is that GreptimeDB has its distributed cluster open sourced, while InfluxDB only open sourced the standalone version. So GreptimeDB can be extended to any scale, while InfluxDB OSS can only run a single node server. Another main reason is that GreptimeDB has a 10 times cost efficiency advantage compared to InfluxDB OSS and Cloud, thanks to the cloud-based elasticity and commodity storage. We are finalizing a blog to talk about the comparison of total cost of ownership. Stay tuned. Other advantage includes that GreptimeDB supports query data via standard SQL as we showcased just now, and actually it supports query data via PromQL. This fact allows you to leverage the virtual data analytics and observability ecosystem. And the fact that GreptimeDB supports InfluxDB LAN protocol, as we shown in the previous demo video, allows you to migrate your existing data pipeline from InfluxDB smoothly. That is all for today's demo. You can find more product details on our website, greptime.com. You can always find us on other social media accounts such as X, LinkedIn by searching GreptimeDB. Just a reminder, GreptimeDB is completely open source, and if you are interested, just head to the GitHub and check it out. Any pull request, issue, or discussion is welcome. Should you encounter any product or technical question, you can join our Slack community. Our core developing team is there for help. Note that our DBaaS product, GreptimeCloud, is now open for free with no credit card info required at all. You can register using the link below. Just give us a try, and we are looking forward to your reply. See you next time.